So here the input is applied to the positive non-inverting terminal of the amplifier. So we call this a non-inverting amplifier. And I want to say a few words about this. The first is about the input terminals. So we always assume for an ideal amplifier there is no potential difference between the two input ports. So these are at the same potential. So if we've got Vs at the positive, then we have that same Vs right there. So this potential here is Vs. Now, if you want to find the gain of a non-inverting amplifier, that's V out divided by Vs. You can see this as a potential divider because we assume that there is no current entering the amplifier. So you can redraw this as something like this, where you've got your two resistors, and this point here is Vs. You've got your feedback resistor RL, and you've got R1. Let's just call this R1 for now. Actually, let's just, for now we've replaced it, let's erase this, all right? So let's just pretend that it now looks like this. All right, so this is what the circuit looks like. So this point Vs, this point Vs is this point Vs. So you can find this voltage using a simple voltage divider, and you can find this voltage using a voltage divider. So you can find the ratio of V out to Vs using a voltage divider, because you can see that Vs is simply V out times R1 over R1 plus RL, where RL is the feedback resistance. And if you rearrange that, you can find the gain of the amplifier, which is the output divided by the input voltage, and that gives you this familiar form of the gain for a non-inverting amplifier. Now, in this particular question, it's asking for the current through the load resistor. So it's looking for this current. Remember, we're assuming there's no current entering the amplifier. So it's looking for this current here. So this current really is just this voltage divided by this resistance. So it's the input potential divided by the resistance that's connected to earth. So if I put that back, we can now look at the diagram as it is. You divide this potential divided by this resistance. So it really doesn't matter what the feedback resistance is. It's independent of the feedback resistance. So you can simply say IL equals Vs divided by R1. So in this case, you're dividing by 1K. And Vs in this question is 1. So it's simply 1 milliamp. Now, because we assume there's no current entering the op-amp, then the current passing through this resistance is the same as the current passing through that resistance. So if I want to write it out properly, I would do something like this. I would say IL equals V out divided by RL plus R1, which is equal to Vs over R1, and in this case it's 1 divided by 1K, which is 1 milliamp. So that's how you would find the current, and in general it doesn't matter what the feedback resistance is. You simply divide this potential by this resistance. So that's how you would deal with a non-inverting amplifier with a simple feedback resistance.